Welcome to our lesson on levels of organisation. In this lesson, we will look at quadrat sampling and data handling. The key questions for today are: what is quadrat sampling? How do you carry out random quadrat sampling? How do you carry out transect sampling? How do you calculate a mean? How do you find the mode and median of a set of data? The key words you will need to know are quadrat, random, systematic, transect, mean. Quadrat sampling is a way of counting some of the organisms present in a specified area to find out how many there are in total. This means that some of the organisms are counted over a specific area and the findings are generalised to give an estimate of the abundance of an organism. Organisms sampled using this method must be stationary or very slow-moving, otherwise there is a risk of counting them twice or missing them altogether. Quadrat sampling could be used to find the abundance of daisies in a field or the seaweed present along a seashore. Quadrat sampling involves placing a square, usually 1 metre by 1 metre, so 1 metre square, in certain places and counting the organisms of interest within the square. The quadrat can be placed randomly or along a line transect. We will look first at random quadrat sampling. The dimensions of the area you wish to study should be measured using a tape measure or trundle wheel. Then you find the area by multiplying the length and the width. You could divide the area up into squares and allocate each square a number. A random number generator could then tell you which squares to place your quadrat in. This method is, however, not always possible to use. The alternative is to throw the quadrat randomly over your shoulder without looking, after using a random number generator to decide where to stand. This is to try and eliminate any bias. You should then count the organisms within each quadrat. An organism counts as inside the quadrat if it is 50% or more inside. Those that are more than 50% outside of the quadrat are not counted. You then need to find the area that you have counted, so 10 quadrats would be 10 metres squared, and find the mean number of the organism per quadrat or per metre squared. You can then multiply this by the area of the whole place you are studying. Let's do an example. We'll imagine that this picture is our complete field and it measures 6 metres by 5 metres. This means our field has an area of 6 multiplied by 5, which equals 30 metres squared. We will place 6 quadrats on the field and count the flowers inside. This means our sample area is 6 metres squared. Counting the flowers in quadrat 1 gives us 0, quadrat 2 gives us 7, quadrat 3 gives us 2, quadrat 4 gives us 0, quadrat 5 gives us 8, and quadrat 6 gives us 3. So now we need to find the mean number of flowers per quadrat. We do this by adding up all of the results, then dividing by the number of quadrats, as follows. And we can round this to 3. This means there is a mean of 3 flowers per quadrat, or 3 flowers per metre squared. So we multiply this by our whole area, which is 30 metres. So 30 multiplied by 3 equals 90 flowers in the whole field based on our sample. If we count the flowers for the whole field, we can see we are not too far off. Task: try this exam question. A student was asked to estimate how many clover plants there are in the school field. The image below shows the equipment used. This is the method used. Throw a quadrat over your shoulder. Count the number of clover plants inside the quadrat. Repeat step 1 and 2 4 more times. Estimate the number of clover plants in the whole field. A. What is the tape in the image above used for in this investigation? B. The teacher told the student that throwing the quadrat over his shoulder was not random. The method could be improved to make sure the quadrats were placed randomly. Suggest one change the student could make to ensure the quadrats were placed randomly. C. The table below shows the students' results. The area of the school field was 500 metres squared. The quadrat used in the table above had an area of 0.25 metres squared. Calculate the estimated number of clover plants in the school field. And here are the answers. Another mathematical value that we can calculate is the modal value. This is the most common result. For these answers, the modal result is 11. We find it by identifying the number that occurs the most. Task: find the modal value for the following data. Extension: find the mean value for the data above. The modal value for the data is 3, as this occurs the highest number of times. The mean is calculated by adding up all of the numbers and dividing by the number of them. There are 10 numbers, so it is 38 divided by 10, which equals 3.8. Another value we can find is the median. This is the middle number when all of the values are placed in numerical order. If the middle lies between two numbers, add the two numbers and divide by 2. The median of this data is between the two 3's. So 3 plus 3 equals 6, then divide by 2. 6 divided by 2 equals 3, so the median is 3. Quadrat sampling can also be used to monitor a change in abundance through an area. This could be looking at a specific organism and seeing how the abundance changes as you move away from a feature such as a tree or path, or even the seashore. The change in abundance also often accompanies a change in an abiotic factor, such as light level, moisture level, soil pH, or height above ground. Task: what would you expect to find happens to the abundance of daisies as you move from a large tree out into an open field? In the shade of the tree, we would expect to find less daisies. As the light level and nutrient level of the soil increases as we move away from the tree, we would expect there to be more daisies. If we find out where in a certain space an organism is more abundant or less so, we are finding the distribution of an organism. Quadrat sampling along a transect or a line tells us about an organism's distribution. When completing quadrat sampling along a transect, a straight line is marked out. A quadrat is then placed systematically along the line, for example, every 2 metres or every 5 metres, depending on how long your transect is. The organisms within each quadrat are then counted as normal. An example of transect sampling would be investigating the distribution of dandelion plants across a field between two trees. These pictures from an exam question show how the transect was marked out between the two trees, and the results from placing a 1 metre squared quadrat every 2 metres. Task: why do you think there were no dandelions under the trees? Extension: why do you think there were no dandelions at 16 metres? Under the trees, the dandelions may not get enough light or nutrients from the soil. At 16 metres, the dandelions could have been eaten by an animal, or it could be where people walk more regularly, so they cannot grow there. Task: what is the mode of the data shown in the graph? 4 is the most common number of dandelions. Extension: why is the mean not a good indicator of distribution of dandelions? The mean is not good to indicate distribution, as it gives the total number of dandelions in the quadrat divided by the number of quadrats. This does not give any information about where the dandelions are.